Okay, so the recording has been started. Okay, fine. So let us proceed. So slightly let me just rewind whatever we have discussed. We started our discussion here, 2D and 3D geometric transformations. We saw all the types of transformations. What are the different transformations? We have move, rotate, scale, mirror, stretch. So all these we have to deal with in detail. We have to see the matrix formula for each of them. And that's what we proceeded to do. Here you can see the matrix formula for move. Here you can see the matrix formula for rotate. Rotate. Fine. Next, you can see here we have found the formula for scale. Then here, this is the formula for mirror. What else is left? Is there anything left? Anything is left here? Oh. Uh, okay. So okay. Fine. So mirror was the last one, right? Yeah, mirror was the last one. We also have something called stretch, but that stretch we will not have any matrix formula for that. The matrix formula will be almost same as the transform or the move. Fine. So the same equation can be applied in even in scale also, stretch also. Fine. So this is move, and the same formula, same matrix can be applied for stretch as well. Okay. And now let's go ahead and do some problems. Okay. Yeah, let's do some problems. Ready? Ready for the problems? So these problems, in every question paper, there will be at least one problem, and depending on how complex the problem is, you will either get just 2 marks or 6 to 8 marks. Fine. So let's proceed. So let's take a point P. Let's take a point P. Let me take the coordinates as okay, 10, comma 20, comma 30. Okay. So the point P has coordinates 10, comma 20, comma 30. Sorry, this is, we are still doing only 2D, right? So only x and y coordinates. So 10, comma 20, let us say the points, this is a point. So now we have to first rotate um, anti-clockwise, rotate anti-clockwise um, by 60 degrees, let us say. Then move it by a distance of 10 in x direction and 15 in y direction. Fine. This is how we have to move it. And then let us say we have to mirror it, mirror about y-axis, mirror about y-axis. What else? So let us scale it next. Okay. Or else, I think the problem is difficult enough right now. So we'll have to perform these three transformations on the point. So A, we have to rotate it anti-clockwise by 60 degrees. Then we have to move it by 10, 15, 10, 15, 10 in x direction, 15 in y direction. Then we have to mirror it about the y-axis, and then we have to find the final coordinates. Find final coordinates. Okay. So I hope you have written down all the previous coordinates. Sorry, the matrix formulae for all these, for rotate, for move, and for mirror. You should know the matrix formulae. Okay. So now let us start implementing. So first step, take a different color. Okay. So first step. Okay. This is where the solution is actually beginning. What is the first step? We have to rotate it anti-clockwise by 60 degrees. So now what is the formula for this? Let's say x2, y2. x2, y2 we have to find. And what was the formula? What was the matrix formula? What was the matrix formula? It was C minus S, and C. Isn't it? Is it correct? What I have written, is it correct? Now here we have x1, y1. Fine. So what is C here? C means cos of theta. S means sine of theta. So now what is the value of theta? The value of theta is here. Now anti-clockwise is taken as positive and clockwise we take it as negative. Clockwise is negative, anti-clockwise or counterclockwise, anti-clockwise is taken as positive. Fine. So here in this case we have to go anti-clockwise, so we have to take theta as positive 60 degrees. So now we substitute. So cos of 60, sine of 60. What is cos of 60? What is cos of 60? Find out. Here I have this calculator. So we have 60 cos. What do we get? 0.5. We get 0.5. Correct. Then we need sine 60. So let's go ahead. Okay. 60 sine 0.866. So 0.866. Okay. So these are the values of C and yes. Now C, yes, here this is minus yes, and here it is yes. And what about x1? X1 value is how much? What is the value of x1? Shall I call your names? Because you people never respond if I don't call the names. It's very difficult. Yeah, roll number 16, Vaishnavi. What is the value of x1 here? X1 is the initial point, right? So this is x1, y1. So how much is x1? 10. How much is y1? 20. Correct. So now we have to substitute all these values here and we will get the value of x2, y2. So C is 0.5, yes is 0.866. Now here it is minus yes, so minus we have to take. Here it is plus, and here it is like this. And then here xy. So this is 10, this is 20. So now you know matrix manipulations, matrix, how to do the matrix multiplication. We have to proceed in this direction, and this we have to proceed downwards. Correct. So do this. So 0.5 into 10, 0.5, sorry, 0.5 into 10 minus 0.866 into 20. So this is what we will get here in the upper side, minus 12.32. Right. So this is the first value we get. And then in the second value, we have to again take 0.866 multiply this with 10 plus 0.5 multiply with 20. We get 18.66. We get 18.66. Okay. So these are the coordinates. These are the coordinates after what have we done? We have rotated. So after rotation, these will be the coordinates. After rotation, this will be the coordinates. Okay. So next, let's take up x3 y3 x3 y3. Let's take up. So once again, what you have to do now, you have to move it. So how to do the move function? So x2 y2 we got it. X2 y2 we got in the previous step. So to this you have to move it. So motion, how to do the motion? You have to do a and b. You have to just add it with a and b. Correct. So now again, tell me what is x2 y2? What is x2 and what is y2? X2 we have found it here, and y2 we have found, let's say here. Okay, this is x2 and this is y2. So these two we found. What about a and b? What about a and b? What is a and what is b? So a value is here. This is a, this is b. So a value is 10, b value is 15. Okay, so now substitute them. Take x2 y2, so minus 12 comma 32 and 18.66, and add this with 10 and 15. Okay, so now what is the final value? Find it. What is the final value? So that is minus 12.32 plus 10 is minus 2.32. Minus 2.32, and then
33.86.
33.86. Let me confirm. Okay, 18.66 plus 15, 33.66. Very good. Right, 33.66. So these are the coordinates after what? After after moving. After moving. Correct. Please respond. Yeah, if you are responding, then I'll get a confirmation that yes, some students are listening. If you're not even responding, then I'll be in a total confusion. I'm explaining all these things, but whether you're understanding, not understanding, that's what the doubt I'll have. As far as possible, don't rely on the recorded videos. Even though we are recording the videos, get all your doubts cleared in the live class, because I'm here to clear your doubts. Fine. But if you're watching the video, then it may not be possible for me to get a doubt, to clear your doubt. Fine. So as far as possible, get all your doubts cleared here itself. The next we have x4 y4. So what we have to do next? We have to perform the next operation, that is mirror. So we have to do mirror about y-axis. So what is the formula for mirror about y-axis? What is the matrix for mirror about y-axis? 1. These two values will always be 0. Okay. Then if you are mirroring about y-axis, this term has to be minus, this term has to be plus. Isn't it? Is it correct? And whatever coordinates we got in the previous step, those we have to apply here. So this is x3, this is y3. So both these we have to take here. Okay. So now let's proceed to solve this. Minus 1, 0, and 0, 1, 0, 1. Okay. Now multiply this with mm, minus 2.32 and 33.66. Multiply, what do we get? Minus 1 gets multiplied here, so we get 2.32. And the second one, we get 33.66 as it is. Correct? So this is the final answer. That's what we have to do, right? Is this the final answer? Is this the final answer? Come on.
Yes, sir.
Okay. So now what we will do, we'll take this AutoCAD sheet and we will perform the same operations what we have seen here. We will perform using AutoCAD. Okay. We'll perform using AutoCAD. Now you can see this is the origin, and now let us place the first point. Where is the point placed first? 10, comma 20. Okay. So you can see that a small point has been placed here. Can you see this point? Let me change the style of the point. Now the point is visible. Is it visible? Okay, so this point, this is a point here, and this is x-axis, y-axis. Okay, x and y-axis are here, and this is the point which we have to on which we have to perform all these operations. Ready? So first, what did we do? We did rotation. So I'll just select this object, give rotate command, rotate command. So about which point we have to rotate? About which point we have to rotate? About which point we have to rotate? About the origin. You have to rotate it about the origin. Fine. So rotate 0, comma 0. That is, we are rotating about the origin. Fine. Now you can see the rotation is happening about the origin. Now we have to rotate in anti-clockwise direction by 60 degrees. So in AutoCAD also anti-clockwise is taken as positive. So let us rotate by 60 degrees. Now the point is here. Fine. So after rotation, you can see the coordinates that we got. They were 12, comma 32, 18, comma 18.66. So let us check it. Let us cross verify whether that is the same. Chaos map from here to 0, comma 0. Okay. So this is the y coordinate. You see, is it the same? That's what we got here also in calculation. And x coordinate. So x coordinate is 12.32 and it is in negative direction. And that's why we can see here we got negative 12.32. Correct. So the first one we confirmed using AutoCAD. Next, what did we do? We moved it. We moved it. Right. So now let us move this. Okay. Let us now move this. So first we will move in x direction by what distance? By distance of 10. Okay. And then we will move in y direction by how much? By 15. Okay. So this is our first step. I didn't choose different colors for them. Okay, no problem. So this is the second one. Mhm. So this is the first step, A step, let us say. This is the B step. After B step, this is we get. Once again, where the y coordinate, how much we got? 33.66. That's correct. And x coordinate, how much did we get? 2.32. and that again is on the left side of y-axis. Hence, we are calling it as negative. Hence, we have negative. And finally, we have to do the mirror about y-axis. So once again, I will take this point, mirror mi into about the vertical axis, enter. Now this is the point we got finally. So this point we got after performing the step C. So now once again we have to check the coordinates of this. So let's take linear coordinates. Fine. So we can see this is correct. This one I'll just place it on the left. This is on the right. So this is 2.32 on the right side of y-axis. Hence it is positive. Fine. So here you can see this is the final thing, and y distance is again the same. Okay, 33.33. So here you can see 33.33. Okay, so is this clear? Please confirm, is this clear? Any doubts here? No doubts?
Sir, C point is not
Here
visible, sir.
says C point is not visible, it's here. Okay. Okay, I'll do one thing. I'll just reduce the thickness of dimensions so that you can see the point more clearly. Let's just turn this off. Okay, so this is the point C. Can you see now? This point is B, this point is C, this point is A. Okay, got it?
Yes, sir.
Okay, so shall we move ahead? Okay, now let's learn something that is called as homogeneous transformations. Next, we have to take up homogeneous transformations. Ready? So even though homogeneous transformations, they have not been mentioned in the syllabus, but I think they will definitely ask questions on this. They will definitely be asking questions on this homogeneous transformations. Okay, so we'll have to be perfect with this. So let us say normal method and homogeneous method. Homogeneous method. Yeah. So the matrix formulae you have to write in normal method first, and then we will convert them into homogeneous. Okay, let me just move this aside. Okay, so now the matrix formulae. Matrix formulae. So first let us note down all the normal formulae. First for move, then for rotate, then for scale, then for mirror, stretch we will not need it anyway. So normal method, what we have to do here, x2, y2, the final coordinates can be found as x1, y1 plus, है ना, plus AB. So what is this? This is matrix addition. Matrix addition. Matrix addition. Fine. Or else let me take a different color for this. Okay. Take a different color for this. So this is matrix addition. Okay. Next, let us take up the next thing, that is rotate. So what is the formula for rotate? What is the formula for rotate? X2, Y2, the final coordinates. We get it after multiplying the initial coordinates, that is x1, y1. So what we have to multiply this with? C minus S, yes, and C. Okay. Oh, what happened? Okay. So this is what we have to multiply. So when you multiply this, then you get rotate. So what is the kind of mathematics involved here? So this is matrix multiplication. This is matrix multiplication. Here we have to do matrix addition. Here we have to do matrix multiplication. Then moving next, what we have to do next in scale? What we have to do in the scale? Hmm? On an answer. What we have to do in the scale? Is it matrix multiplication or matrix addition or scalar addition? What exactly it is? Let me take the same color again. So again here x2, y2, the final coordinates are got from x1, y1, the initial coordinates. How do we get this? Hello, ma'am, I'll call you after some time. Yeah, I'm in the middle of a class. Okay, sir. Thank you. Okay. Hello, am I audible? Are you getting my voice?
Yes, sir.
Yeah. So in the scaling, what we have to do? Plus or minus 1, plus or minus 1. This is 0, this is 0. So once again, what are we getting here? What kind of operation we have to do here? So this is matrix multiplication again, isn't it? And this is for what kind of, sorry. Is it correct? What I have written, is it correct? Hmm? Respond, ma, please. In fact, if you are so silent, even I am getting sleep, and that's why I'm ending up making mistakes all this. So this formula that I've written, it's actually for mirror. What will be the formula for scale? What will be the
Sir,
formula?
the screen is stuck. We can't see anything.
Okay, you can just inform me, na. If you stay silent,
So,
how will I get to know?
blank.
Okay, I'm sharing it once again. Is it visible now? Confirm?
Yes, sir. It's visible.
Yeah.
Yes, sir.
Okay. So we have x2, y2. What is the formula for scaling? What is the formula for scaling? X1, y1, of course, the initial points. So we have to multiply this with some matrix. What is the matrix? Yes, x, yes, y, and these are zeros. So once again, what is the kind of mathematics involved here? Matrix multiplication, isn't it? Matrix multiplication. Once again, here this is non-uniform scaling, right? Non-uniform scaling. But if we have to do uniform scaling, For uniform scaling, what we have to do? What we have to do? We just have to multiply a factor, yes. So x factor, we just have to multiply. Okay. So what is the kind of mathematics involved here again? So this is matrix. So scalar multiplication, you can say. Sure. That's one. You just say scalar multiplication. Fine. So because the scaling factor, yes, has to be multiplied to all of the entities. You have to multiply that to all of the entities. So you can see here now that there are so many different kinds of operations we have to do. Right? At some places we have to do matrix multiplication. At some places scalar multiplication. At other places still other type of multiplications and all. So this is what makes this very difficult to apply with the computers. Fine. Very difficult to apply with the computers. And that is why this other system was introduced. What is that other system? Homogeneous. Homogeneous system. So now with homogeneous system, you will find that the process becomes much simpler. So this is normal. This is homogeneous transformation. Fine. So now once again we'll be taking up the same formula we have to find once again, but instead of normal method, we'll have to now find it for this method. Okay, we separate this here, this. Okay, so this is a table. Okay, so let's calculate this, right? Fine. So now let's write down the formula. The same formula we have to now write in homogeneous form. Okay. So now matrix addition. So in the homogeneous matrix, what happens is instead of just having a 2 by 2 matrix, we will get a 3 by 3 matrix. Okay. Instead of just getting a 2 by 2 matrix, we will get a 3 by 3 matrix. Okay. And what happens here is here we get rotation, we get scale, we get mirror. So all these functions come here, and this is where we get the translate. This side itself. Okay, translate. Translate means move. So move or translate, we will get here, this side. At the bottom here, this is always called as null. And null means this will always be 0. And scale we will get here. And what kind of scale? Actually, uniform scale we will get here. Uniform scale. Uniform scaling, if you are doing, you will get it over here. Fine. So this is how the homogeneous function is going to work. This is how the homogeneous function is going to work. Okay. So in case we are not doing rotation, scaling, or mirror, then at this place, in this place, you will get identity matrix. You will get identity matrix. If you are doing the scale, mirror, or whatever, then you will get that matrix over there. If you are not doing it, you will get identity matrix. So in this move transformation, we are not doing rotation, scale, mirror, or anything. We are just moving, and we are not even doing any scaling. So all these values which you are not doing, they will remain as identity matrices. Fine. So let us write down the homogeneous matrix here. Let us write down the homogeneous matrix here for the move command. So I told we are not doing any of this. So this will remain identity. So this is the identity matrix. This matrix will always remain null matrix. And this is where this is the place where we will get the translate function. So we are doing translation here by A and B in X and Y direction. So A in X direction, B in Y direction. And this is where you get uniform scale. So are we doing any scaling here? No, we are not doing any scaling. Hence, this scaling factor will also be just 1. Okay. So this matrix, we'll have to multiply this. Just remove this. This matrix will have to multiply it with the matrix. Okay. So what is the other matrix? The coordinates, the point. So the point here will be x1, y1, and what else? Here we just have to append this with 1. Okay, just have to append this with 1. So when we perform this multiplication, we will get the right result. Okay, so shall we confirm it? Shall we confirm it with the same problem? Let's go back to the previous problem and let us now do the same problem with this method, homogeneous method. Ready? So where did we move it? Yeah, this is where we moved it, right? Moved it here. This is where we moved it. I'll just put the equation here. Right. So let us move this. So initial points. What were the initial points here? Minus 12, minus 12.32, 18.66, 18.66, and 1. So these are the final points. Coming to the matrix. As I told, this will remain 1, 1, 0, 0. This is null matrix. This is scaling matrix. And this is where we get A and B. So AB value, what are the values of A and B? A is 10, B is 15. So now if you multiply this, what do we get? What do we get when you multiply this? Once again, we have to take it this side and multiply and add these values. Okay. So do it. What do we get? 1 into minus 12.32 plus 0 into this value and plus 10 into this. Yeah. So this is minus 12.32 plus 10 minus 12.32 plus 10. So again, we end up with the same result that we got earlier. Fine. So what do we get here? Minus 2.32. Now do the second one. The second one, we have to again come in this direction. Multiply all these values with this. Fine. Moving in the column. And then we have to add them. So 0 into minus 12.32 is 0 itself. 1 into 18.66, that is 18.66, plus 15 into 1, that is 15. So once again, we get 33, 33.33, 33.66. Okay, and finally the last one, 0 into this is 0, 0 into this is 0, 1 into 1 is just 1. So 0 plus 0 plus 0 is just 1. So are we getting the same result? Are we getting the same result? Is it same or is it different? You see, we got minus 2.33 here. Same value we are getting here. And here we get 33.66. So here we are getting same 33.66. So this one at the bottom, this is just added to make it consistent. That one is added just to make it consistent. So you just have to ignore this last part. You just have to ignore this last part. Fine. So this is just to be ignored. Okay. So indeed, we got the same result with this matrix, homogeneous matrix method. Homogeneous matrix method, you can see that it is a lot more complicated, isn't it? Which one is more complex? Which one is more complex? Come on, answer me. Which one is more complicated? Hello?
Homogeneous.
Yes, ma'am? Homogeneous is more complicated, right? Then why are we going for complicated? What is the advantage with this? This is more complicated. This is much more simple. Then why are we going for this complicated method? The reason you will come to understand when we write homogeneous matrices for all these motion for all these transformations. Okay. So next let us write for the rotation. Next let us write for the rotation. Okay. So once again here, instead of just a 2 by 2 matrix, we will get a 3 by 3 matrix. Okay, we will get a 3 by 3 matrix. So once again, let's divide this like this. So as I told here, fine. So as I told here, rotation is going to come here. So in this place is where we'll get the rotation. What is the formula for rotation? It is C minus S, and C. So are we doing any translation? Are we doing any movement here? No, we are not doing any movement. Because we are not doing any movement, this value will be 0 here. Are we doing any uniform scaling? No, we are not doing any uniform scaling. So this value will just be 1:1. And this value will always be 0. Irrespective, whatever different transformation we may be doing, but the null matrix will always continue to remain as 0. Sorry. Okay. So this is the formula for rotate. This is the formula for rotate. Once again, anti-clockwise here, for anti-clockwise, we have to take theta as negative, theta as negative. And for clockwise, theta is assumed to be positive. Okay, theta is assumed to be positive. Next, let us go for the scale. So scale formula we have written it here. So the same formula now we have to write it in homogeneous format. Once again, we will get a 3 by 3 matrix. Let's just divide this here like this. We are not doing any scale, so scaling is 1. This is always null matrix. We are not doing any translation or movement, so movement will also be 0. Then this scaling matrix Sx, Sy will come here. Okay, so this is what happens to the scaling matrix. So once again, if you want to use this scaling matrix, what you have to do? So the coordinates x1, y1, and 1 you have to multiply here. Okay, x1, y1, and 1 you have to multiply. Then when you multiply, you will get x2, y2, 1. You will get x2, y2, 1. So the same matrix we can apply it everywhere. The same we can apply everywhere. Okay, fine. So lastly, for mirror, once again we'll have to write a 4 by 4 matrix. Okay, so once again we can just divide this into like this. We are not doing any uniform scale, so 1. We are not doing any movement, so 0. Null matrix is always null matrix, and here minus plus or minus 1, plus or minus 1, 0, 0. So now this plus or minus we have to again take depending on which axis we are mirroring it upon. Okay, so that is how we have to do. So once again we have to just multiply this with x1, y1, and 1. This is the input matrix, the initial point. And when you multiply this, you will get the final point x2, y2, 1. Okay. Okay, so let me write it here as well. This is x1, y1, 1. Let me move this aside. this will move it aside. So this will give us the final point x2, y2, 1. Okay. So now just compare these two. Here we are doing matrix addition. What are we doing here on the right side in homogeneous method? What are we doing here? Matrix multiplication, no? Isn't it? What are we doing here in rotate? What are we doing here in rotate? Come on, tell me. Matrix multiplication. What are we doing here? What are we doing here? Again, matrix multiplication, isn't it? What about the last one? What are we doing here? What are we doing here? Again, the matrix multiplication. At all these places, we are doing the same matrix multiplication, isn't it? Whereas here, this is addition, and we have matrix multiplication, we have scalar multiplication, we have matrix multiplication, matrix multiplication. So these are different type of operations. And here, all these operations are same. All these operations are same. And this is why it is called homogeneous. This is why it is called homogeneous. Homogeneous. Are you getting it? Is this clear? Isma, is this clear? Please respond.
Yes, sir.
So please note down all these matrix manipulations. Write down all these formulae, and in the next class, we will do some problems based on this. Not only this, we will also have to write down the formula for 3D manipulations. Fine. So move in 3D, rotate in 3D, and all of these we have to do it in 3D. So today we have done only 2D. 2D rotate, 2D scale, and 2D mirror. In the next class, we will be going to the 3D operation. So 3D move, 3D rotate, 3D scale, and 3D mirror. So in the next class, okay, fine. So we'll just again go ahead with the same table. First, we will make the normal matrix formulae, and then we will go ahead and write down the homogeneous matrix formulae. Okay. Note this down. Everyone noted it? Note this, everyone. And you can stop here. So this screenshot, I'll just take it, send you on WhatsApp. Any other screenshots you want? The screenshot also I will share it. This is the problem we solved. You need these also? Okay. Oh, why it's not coming? Mm-hmm. Then more. This is for 2D transformation, that is move. In fact, we will come back to the same slides. We will come back to the same slides in the next class. And in the same slides, we will write down the formula for 3 dimensions, 3-dimensional iterations. That's why I've left so much of space at the bottom. And your scale. I hope you are maintaining good notes. You're writing it all down at a convenient place. Any more doubts here? Any more doubts? No doubts. Okay. Thank you for being so patient, pin droppingly patient, and not so thankful for you being so silent, not responding to the questions. Hope next time onwards you will be responding in more number. Fine. Thank you. You can leave the class and join whatever is next. What is the next class?
FEA, sir.
FEA. Okay. So you can leave this and join the next class. Thank you. Bye.